In this video, I'll show you how to use GeoGebra to compute a hypothesis test for one sample proportion. So first we'll go to geogebra.org/classic #probability. And when you enter that, you're going to see this screen up here. It's the distribution menu where you can choose different distributions. You're probably familiar with the normal distribution at this point. What we want to go to is statistics. We'll choose the statistics tab. And we're going to choose the hypothesis test or confidence interval that we need to do. We are going to be doing a z-test for a proportion. So it says z because we use a normal model and proportion for doing one proportion test. So in the boxes up here is what we fill in, and then down below this is our result. So the null hypothesis is the value that you'll see written in your hypothesis statement. So it's the same number that's written in the null and alternative hypothesis. So let's say that our null hypothesis is, let's go to an example here. A researcher boiled her hypothesis down to the following information. H naught P is equal to 0.7. All right, so let's put in 0.7. And going back to the question, HA is P less than 0.7. So this is a left-tailed test. The little arrow's pointing to the left. We're trying to see if the proportion has decreased since we once gathered data. And we're using a significance level of 0.06. And we're also given the information that X, the number of successes, is 107, and N, the sample size, is 160. And the goal here is just to find the p-value. So 107 and 160 are the numbers that I want to remember, because the next part of the box is how many successes are there. 107, and the sample size is 160. You'll notice that sometimes you'll see a capital N, sometimes you'll see a lowercase n. That's okay, as long as you understand that it is the sample, and then the successes, that's your X, is how many successes you had out of that sample. We don't need this keyboard part down here, so we can X out of that. And as soon as you type in all that information in the result, the z-test for the proportion, you're going to see some of the same information spat back out at you. 107 for successes, 160 for N. Z, this is your test statistic. So it's the sample proportion, so the ratio of 107 to 160, minus the hypothesized proportion, 0.7, divided by that standard error. So that's your z value. And since we're looking at a left-tailed test, as I chose up there, the area to the left of negative 0.86 is about 0.19, or almost 20%. So the p-value is just labeled with p, and it is 0.1942. So it's actually a pretty large p-value, showing that the sample proportion hasn't changed too much from what we hypothesized in the null hypothesis. So there is a difference, yes, but it's not a significant difference, not one that we'd be likely to see just given chance. So our data is sort of usual, if you will. So we would go back to the question here, find the p-value, round it out to however many how many decimal places we had. 0.1942 is the p-value.